Okay, so I have another video that does more of this, but I wanted to add this part in. So the fundamental theorem of calculus, part one. So if you have a continuous function on a closed interval and it's differentiable on the open interval, then the definite integral from a to b of f of x is equal to capital F of b minus capital F of a, where capital F of x is the antiderivative of f of x. So write that out, and then let me show you what that means. That means, as Helen was asking, can we find the exact area under a curve? We can. So let me show you these two, and hopefully I can make this a short video since I'm giving you another video too. So this one, it gives you a linear one just to show it. So it says, consider the function f of x equals negative 2x plus 3. Calculate each of the following definite integrals according to the fundamental theorem of calculus, and then shade the area that that represents. So first of all, negative 2 to positive 1 would be like this. And I just want to show you that if it's a linear function, you could actually find the area of that using geometric formulas, and that would work as well. But if we want to, I'm going to go ahead and shade it first. This is the area that we're finding. If I do this, if I do the fundamental theorem of calculus, this is equal to the antiderivative, and then plugging in the top bound minus the bottom bound. So first of all, think about what the antiderivative of this is. The antiderivative is negative 2x squared over 2 plus 3x plus c, or that's really just negative x squared plus 3x plus c. Normally when you do a definite integral, you don't have to put the plus c, but I just want to show you why, and then we'll do the next one without it. So when you do this, to show the work, you draw a line and you put your two numbers, like negative 2 to 1. And I'm going to do capital F of b, which means using this formula, I'm going to plug 1 in there. So that's negative, and then 1 squared plus 3 times 1 plus c. And I'm going to subtract, because I'm doing capital F of 1 minus capital F of negative 2. And I'm going to use parentheses here. Negative of negative 2 squared plus 3 times negative 2 plus c. Be really careful with your negatives here. You have to do the exponent before you do the negative. That's why I did parentheses here. So this would actually be negative 1 plus 3 plus c minus, I'm going to keep parentheses here for a minute because this would be 4, but then that would be negative 4 minus 6 plus c. Or this would be negative 1 plus 3 plus c plus 4 plus 6 minus c when I distribute this negative. So look what happens every time. If you're taking f of b minus f of a, every time the c's are going to cancel out. So you don't have to put the c in there. Or if you do, you'll see that it cancels out. And then 10 plus 3 is 13 minus 1, which is 12. Now on this one, I just do want to show you that you could do like this is a trapezoid, or you could break it up into a rectangle. Like you could just do the geometric area here. I'm going to do a trapezoid where the height would be 1, 2, 3, and the sum of my bases would be, this sum would be 1 plus 7. So 8 times 3 is 24. Half of 24 is 12, because that's what an integral is. It's the area of that region, right? And this is how we can find the exact area using antiderivatives. So look at this one. Same thing, but now we're going to do from 2 to 5. So from 2, which is right here, to 5, which is right here. And this is going to be this area, right? It's the same antiderivative, right? It's still negative x squared plus 3x. I'm going to drop the c now because that's how we normally write it. And I'm going to do that from 2 to 5. And this is notation. Draw a line from 2 to 5. And then you always start with the top bound. So I'm going to plug 5 in there first. So negative 5 squared plus 3 times 5 minus, I like to do parentheses here, negative 2 squared plus 3 times 2. So that's negative 25 plus 15. So it'd be negative 4. But the negative out there makes it plus 4. I don't know why I changed it to an 8. And then 6, but that would be minus 6, right? So 25, negative 25 plus 15 is negative 10. So negative 10, 9, 8, 7, 6 minus 6 is negative 12. So what do you notice about this? Like when I got a positive number versus when I have a negative number, that's what we're going to talk about on the next video.